actually, it's not really anything new, but I've included this lesson just to really focus in on dealing with fractions, because fractions make everything more difficult, right? I know that they do, and as an academic math student, you've got to be good at working at them. And I didn't even put Charlie in because he can't cope with fractions. He's just a pug. But you're not pugs. You can do this. Okay, so yeah, what do we want to do? We want to do algebra, adding and subtracting, and distributive property, do everything that we do when there's letters and there's fractions. And the first little thing is, this is something I consider implied as I do these questions. I assume that you understand where I'm coming from on this. And that's that if I have, 2/3 x, that's how I would say that, right? Well, it's the same thing as 2x over 3. And that makes, it is important when dealing with fractions, to separate the numerator and the denominator. That x is part of the numerator. Okay, and that's my point there. And it makes the whole thing easier. And just the reason, if you're not sure why I'm saying that, it's because 2 over 3 times x is the same as 2 over 3 times x over 1, right? Because x over 1 is just x. And then that means you have 2 times x in the numerator, 3 times 1 in the denominator. Okay, so I'm going to sort of frequently, you'll see a question where it starts out looking like, like this part, and I'm going to jump into this form because this is the form you need to separate numerators and denominators. Excuse me. Okay, moving on. So let's just do a simple common denominator adding. I like to have this on here so I don't want you to get far ahead of me. So first of all, jumped into that first step right away. Excuse me. Jumped into that first step right away. And we're just adding. And you probably, hopefully remember with adding fractions then, the numerator doesn't change, right? You just as long as you have a common denominator, sorry, the denominator doesn't change. As long as you have a common denominator, it just can become the denominator, and then you add the numerators, and therefore in this case you end up with 6x over 3, which you can simplify this further because 6 divided by 3, remember this is just a divide, 6 divided by 3 is 2, and you end up with 2x. Okay, so that's a simple adding fractions with letters. Okay, woo, okay, you'll love this. You're going to love this. I think all the writing on the side might confuse matters a bit. I'm going to keep it there. You can write it down if you want to, or you can just read it and see if it makes sense to you. If you find it's helpful for you, write it down. You may find it's less helpful for you. Okay, pretty much what I'm saying in the purple is that you can't, if I'm adding fractions, like anything else, you have to get a common denominator. Really, nothing's different than you've done before. We've done this before, right? And you did it before in elementary school. You got to get that common denominator. The point is there's just an x involved, right? So, the way that you do that, the way that I do it for sure, is you find, you might have learned to find the lowest common denominator. I don't know if that's necessary. You can do. I think it's easier to do that at the end. So I just say, follow my arrows. This one has a 5 as a denominator. I got to get a common denominator, like no question about it. That's the most important thing. I'm going to choose the common denominator, which is the product of these two, which is 315, right? And the way that I do that is I take the 5 from this side, and I multiply top and bottom of this side, right, by 5. Remember, 5 over 5 is just 1. So I'm not changing anything by multiplying it by 1. Similarly over here, I take this 3 and I multiply top and bottom by 3. So now what I've got, just to take it another step, is I got 15 on the bottom because you just multiply. When you're multiplying fractions, you just multiply top, multiply bottom. You don't have to worry about common denominator, none of that. So these two multiply to get 15 at the bottom. 5 times 2x is 10x. Similarly over here, 3 times 4x is 12x and 15. Now it's just an easy add, 22x over 15. Okay, so that's what it is. If the purple helps you, please get to a point where you can read it all and write it all down, and that's great. But that's how you add fractions that have a different common denominator. Of course, you've done that before. There's just an x involved now, right? Subtracting, Same idea. Exactly the same idea, actually. Find a common denominator, right? Same thing, I'm going to multiply this side by 5, this side by 3, so I get 15 on the bottom. Now I've got 10x minus 12x, that's the difference, it becomes minus 2x over 15. And you can just leave it like that. Or you could put the minus sign right here, it doesn't really matter where it is. Okay, exact same. Multiplying. Remember when you multiply everything. You multiply tops, you multiply bottoms. So now we have 2a. Remember I rewrote it right away as 2a over 3. There should be an equal sign there. Bad form on my part. Right there, there should be an equal sign. Okay. So again, that's just rewriting it. Now I multiply 2a times 4a, so that's 2 times 4 is 8. A times a is a to the 1 times a to the 1, which is a squared. And 3 times 5 is 15. Okay? Okay, distributive property with fractions. Now we did do this in class already, but let's go ahead and do it again. First step is actually to distribute, right? So I'm just going to leave it as 2/3 a and 2/3 times 2, right? Because I've multiplied this 2/3 times everything inside. And nice thing is it does leave me with a common denominator. Instead of saying 2/3 a, I write 2a over 3, and here I've got 4 over 3, because it's kind of the same reason that this is 2a. This would just be 2 times 2, or 4 over 3. And actually now I'm done, right? Because you can't add or subtract. I can't simplify something when this has an a and this doesn't. They're unlike terms. I'm done. I don't have to do anymore. And there's the hard one. We've done one like it, but we'll do another one in class tomorrow because they're hard enough. They require. If you want to try it, I'd be impressed if you come in tomorrow trying that on your own right now, and come in tomorrow to class with that, and we can compare our answers. I'd love to see you do that, but otherwise I'll take this one up in class tomorrow. Okay? And that's it. That's it. Good.